All right, so here we have a whole bunch of different topics, some of which we're going to discuss in further depth in this unit. But these are terms that you may already be familiar with, but we definitely should review a little bit. There's some terms that are very common to us, so like population and sample. You know, population being everyone in the world with that we're looking at, and sample being the selection of people from the group that we're looking at. Okay, so if we're doing statistics on the United States, everyone in the US would be our population. The 1,000 people that we survey would be our sample. Okay, and the amazing thing is they've done a lot of study into this, but the amazing thing is that they can actually make pretty good predictions on a population. Even for like the US, you're talking over 300 million people with only 1,000 or so people in the sample. Now the key is how you create your sample and whatnot, but that is kind of an interesting thing. A census would collect information from the entire population, while a survey would collect it just from a sample. Doing an actual sample census is very, very difficult. That's why in the US they only do one every decade. And usually the results don't even get collected and released for like 3 years. Okay? Actually the first ever census that used a mechanical recording device was 1890. It was like one of the predecessors of the computer, and they used little punch cards to record people's information. So I think it was Herman Hollerith was the inventor of that.
Didn't we use that same technology for like elections up until like a couple of years ago?
Punch cards?
Yeah, like that was
Kind of similar idea, yeah. It's people are a little suspicious of digital because it can be hacked. So, yeah. But then we have different things here. We'll talk about types of data a little bit more later when we get to correlation, because it's important that you understand that, especially there. But categorical variable versus a numerical variable, okay? Categorical variable describing a quality or characteristic that can be divided into categories. For instance, if we're categorizing you guys by what color hair you have, all right, that's not a number, that's just your blonde, black, brown, red, whatever, okay? They're categories. Numerical variables are characteristics that have a numerical value, okay? Parameters, a quantity measuring some aspect of the population. A statistic is a quantity that's calculated from data that's gathered. Okay? We use statistics in very broad terms. If you just see a table of values, in sports we call them a player's stats. Okay? Not all of those are actually statistics. Okay? Like in baseball, the number of at-bats that you've had is not a statistic. That's just a parameter. It's measuring something. Your batting average would be a statistic, So, one of the things that can make stats a challenging topic is sometimes we use things in our common vernacular that are mathematically kind of improper. We're also going to look at some distributions and skewing of distributions, and then we'll talk about outliers a little bit, okay? So, those are just some terms that we need to be familiar with right off the bat, okay? Two other terms that we need to consider here. Discrete versus continuous variables, okay? Discrete versus continuous variables. A discrete variable takes an exact value, okay? If I'm talking about the number of students in each class, that's an exact value. It's not that we can't have fractions, but it's just that it's something that we actually counted. Alright? Again, think of this, come on. Think of it as, we're talking about numbers. I think that's why. Had my Bluetooth turned off. So I don't know why my pen wasn't working. Okay. Number values, okay? The result of counting. Alright? Discrete. Now, if you understand these two things, and when we get to looking at different distributions and different things that we're going to do statistically, often recognizing the fact that you have discrete variables or that you have continuous variables will help you when deciding which method to use. Okay? For example, we're going to look at the binomial distribution. We looked at the binomial theorem last year in pre-cal honors, okay? The binomial distribution, if you're doing stuff with that, you have to deal with discrete variables, okay? How many times did this happen, okay? Or how many times could this occur? What's the probability of this occurring so many times? A continuous variable takes numerical values within a certain continuous range, okay? It's not an exact number, it's a continuous range. It's usually the result of measuring, okay? So if we're talking about someone's height, that would be a continuous variable, all right? We have to measure that. And we have to recognize that our measurements are only as good as the tool that we're using to measure them with. If all we have is, something that goes down to the inch, then anything beyond the inch, we're kind of approximating there, okay? And, even if it does look like it's right on the line for 3 inches, then we can't be 100% certain it's not 3.05 inches or something. And one of the things that's interesting about this is the probability of any one specific point is actually 0. So we always consider probabilities of ranges of values, okay? So those are two types of variables that we need to make sure we keep straight here: continuous versus discrete variables, okay? Now, let's talk about some types of data. All right, we're laying a groundwork. I know there's a lot of terminology here that we've got to get straight at the beginning, but types of data. And we're going to actually start with the lower level or the most general type of data and move to the more specific. Okay? So, the nominal scale of data is things that are named or classified. All right, and these are things that we can count. Again, if we're categorizing people by what color hair or by what sport they play or things like that, we're dealing with nominal data. This kind of data, or anytime we're grouping, it could possibly be numerical, but then we're grouping them together. Like the students who got a 3.5 or higher. There's a group of students. Anytime we group things like that, we're dealing with nominal scale data, okay? Certain tools, certain things in statistics can only be used with certain types of data. For example, the chi-squared test can only be used, you got to use nominal data, categorical data, okay? You're classifying things. Moving up from that, we have ordinal scale, ordering values. Anytime we're rating something, and then taking those ratings and putting those things in order, okay? Think about the Olympics that we just saw, the events that are judged. For example, the gymnastics or whatever, they get a particular score, but then they're placed in a rank, okay? There are different tests that use this kind of data. For example, there's one called the Spearman rank. This is one, this is a test they actually use to see if a particular judge might be biased, okay? Because here's the thing, the actual scores don't really matter if you have multiple judges, as long as they're kind of arranging people in the same order. All right, maybe one person gave this guy a 9.8, this guy a 9.5, and this guy an 8.7. This person gave the first one a 9.5, the second one a 9.1, and the third one a 8.2. His scores were all lower, but they were all in the same order. Okay? That's something where ordinal would be the first place, second place, third place, fourth place, and so on. So they actually will do a statistical test to see if any one judge is kind of deviating from everyone else. I remember back when I was little, there was in the figure skating, I think particularly in the Winter Olympics, there was some real accusations of bias on some of the judges, because they would have judges from like 8 different countries, and they'd throw out the highest score, they'd throw out the lowest score, and then they'd have all the others. But they were saying that, you know, some judges from the countries were judging their people really easy and everyone else or their rivals really low, you know.
You weren't allowed to judge your own country.
Well, maybe now, but this was like when I was little, so like 20 years ago or whatever. But but that's another type of thing, and they had statistical tests to try to gauge, okay, yeah, this one judge is really way off. So then you have the ones that were maybe a little bit more used to dealing with, interval scale and ratio scale. These are both numerical scores, and interval has, the reason why it's called interval is because there's an equal interval between values. So the difference between getting a 3 and a 4 is the same as the difference between getting an 8 and a 7. Okay, a 1 unit is the same no matter where you are on the scale. Okay? You know, the difference between first place and second place in a race may not be the same as the distance between second and third. Okay? That's ordinal. Okay? And some of the swimming competitions, what was her name? Ledecky. You know, she won by a huge margin. You know, and she's sitting there waiting for everyone else to finish. So the distance between first and second was huge, but then second and third finished real close. Mm-hmm. You know.
So that's not interval.
So that's not interval. Mm-hmm. That would be ordinal. Interval is things like temperature. Okay? If we're talking about temperature, the difference between, 30 and 40 degrees is 10 degrees. That's the same temperature difference, energy-wise, as the difference between 90 and 100 degrees. Okay? Yes?
I was confused with the ordinal scale when you said, what they do is they compare. Is it important to know the whole, comparing when they got, one was 9.7, 9.5, and 8.7? I was comparing when you said, I was confused when you said that, and one of them was yeah.
Well,
I got
here's the deal. The deal with the ordinal is it's not the actual scores they're getting, it's the order that the judges would be placing them as far as first, second, third, fourth, fifth. Okay? So you might have one judge and it ranks certain people, 5, 3, 2, 4, 1, and the other judge has, 5, 2, 3, 4, 1. Okay? They're pretty similar, so in a Spearman rank thing, that probably wouldn't raise any red flags. They just disagreed on one of them. Okay? Now, The difference is this guy's scores overall might have been higher than this guy's scores. But the key is when you're talking about a winner or something like that is, you know, where they're ranked in relation to each other.
Okay.
You know, so it could be relative, and that's kind of the thing. You don't really care if a judge is really harsh as long as they're consistently harsh, or you don't care if they're really easy as long as they're consistently easy.
Easier, so much harder.
Yeah, exactly. That it's kind of testing consistency. So, let's see, is that two? Okay. Now, the difference between interval and ratio is the fact that ratio has an absolute zero. That's kind of the key here. And the reason why that's key is that if we have an absolute zero, then we can consider things in ratio to each other. Okay? You can't say that 90 degrees is twice as hot as 45 degrees. Because even though technically 0 Kelvin is considered absolute zero, theoretically, there's no, you know, absolute zero to temperature. You could always get colder and colder and colder, or hotter and hotter and hotter, okay? So you can't make those comparisons. When you're talking about a scale that has an absolute zero, then you are able to make those comparisons, all right? For example, if we're talking about, I don't know, if we've got two hunters, okay? They had, back in the spring or summer, they have the python hunters out in the Everglades. They send people out and they hunt pythons because there's an invasive species. They're not native to here. So let's say one guy hunts and he catches 28 pythons, and the other guy hunts and he catches 21 pythons. You can compare them in a ratio, and you can say, well, for every 3 the second guy caught, the other guy caught 4, because 28 over 21 would be 4/3. All right? You can make that comparison, or you can say he caught 1/3 more. Now, one rule that you have to take into account is right here. If you have data that is ratio, it's a higher level. You can generalize that to a lower level. Like if we wanted to take a ratio value and then categorize it and make that into nominal data, we could do that. All right? You know, like a GPA, okay? All those GPAs, that's ratio, because there is an absolute 0 GPA. All right. You could take the GPAs and then categorize them and make that into nominal data. Who are the people who got, say in college, you have summa cum laude and cum laude and magna cum laude. All right. They're categorizing those people. So now we have nominal data. Okay. We could take that and we could put them in a particular rank. You know, we have the number of pythons all of our hunters caught, so now we're going to, you know, award them 1st, 2nd, 3rd, 4th place for catching certain ones. Okay, so you can generalize to a lower level of data. You cannot try to take nominal data and try to force it into being ratio or something like that. Okay? All right. Now, frequency and relative frequency. This is actually kind of a big deal. This is something that pretty much every IB exam is going to have a cumulative frequency table. All right? And we'll look at working with these. Frequency, you guys are familiar with that. The number of times a piece of data occurs. Relative frequency is the percent of the time that that piece of data occurs. Okay? The percent of time. So here we had values 1 through 5. We had these frequencies. Okay? So out of 30, 8 of them were 1s. So 8 out of 30 is 26.7%. All right? That would be its relative frequency. Now, remember I told you discrete data versus continuous data was going to be important? Okay, here's one example, okay? A column graph versus a frequency histogram, okay? All right, a histogram, a frequency histogram is technically for use for continuous variables. And you need to have equal width, okay? So you're not going to make a histogram where one bar stands for going from 5 to 10 and then this one is going from 10 to 20. That would not be a valid histogram, okay? So you have equal width and it's for continuous data. The column graph is used for those discrete variables. How many times did we do this? How many times did we do this? We're counting, all right? There's not this continuous measurement idea, okay?
And are you allowed to skip more, like have different widths for the columns on a column graph? Or no?
Well, they're discrete, so they're exact values.
Oh, okay.
So if you had like for instance, we had 0 4s, you just wouldn't have a bar above 4.
Okay.
So you'd have a gap there. Okay. All right, so again, remember discrete, we're thinking about counting. Continuous, we're talking about things that are measured in general. Okay? So again, I know we're hitting a lot of different terms here, but we're kind of laying groundwork for the rest of what we need to do.